In early 1960s, NATO established a project on the propulsion system by exemplifying the concept of a smart defense initiative to provide an effective self-defense capability for U.S. and NATO surface combatants against some of their evolving threats. One of the weapon systems is named the Sea Sparrow Surface Missile System with Radar Intercept Missile 7, or RIM-7. This NATO weapon system, which was originally developed by Sperry and the U.S. Navy and eventually produced by Raytheon and General Dynamics, has undoubtedly outperformed their expectations since then. So, what does the RIM-7 Sea Sparrow surface missile system look like? Stay tuned to find out the answer. Welcome back to Military TV. In today's episode, we will discuss about one of weapons systems from the largest and longest-running cooperative smart defense initiative in NATO history, the RIM-7 Sea Sparrow Surface Missile System, SSM, or commonly known as RIM-7 Sea Sparrow. So, how is the RIM-7 first initiated? Let's take a look at its short history. The RIM-7 is a radar-guided, surface-to-air missile and was initially developed based on the AIM-7 Sparrow air-to-air missile used by the U.S. Navy and Marine Corps. In this incarnation, the RIM-7 Sea Sparrow was a very simple weapon system, guided by a manually pointed radar illuminator, and was categorized as a lightweight, point defense weapon that could be swiftly installed to existing ships, typically replacing existing gun-based anti-aircraft systems. However, after its introduction in early 1970s, the RIM-7 Sea Sparrow underwent extensive improvement, which was aimed at perfecting anti-ship missile defense capabilities through continued technology improvement. It then became an automated weapons system similar to other U.S. Navy missiles, such as the RIM-2 Terrier. After that, the air-to-air mission was taken over by AIM-120 AMRAAM, while the RIM-7 received a series of upgrades aimed solely at the naval duty. It currently looks like the AIM-7 in general form, except it is now larger, faster, and features a new seeker as well as a launch system capable of vertical launch from modern warships. The RIM-7 missile has been used by the U.S. Navy on 3 ship classes, CVN, LHA, and LHD, and remains as a vital component of a multi-layered air defense system, offering a short-range component that is particularly effective against sea-skimming missiles. Now, let's see the RIM-7 Sea Sparrow general characteristics. As you can see in this video, the RIM-7 Sea Sparrow has a cylindrical body with 4 foldable mid-body wings and 4 tail fins. The wings are hinged at a position approximately halfway down the span, with the outer sections rotating back toward the missile's fuselage, similar to how carrier-based aircraft are done. This allowed them to be stored in tighter container tubes in the new Mk-29 launcher, where they would automatically flip open when released. In addition, this RIM-7 Sea Sparrow has a length of 3.64 meter, with diameter of 20.3 centimeters, wingspan of 1.02 meter, and weight of 225 kilograms. Also, built with Hercules Mark 58, solid propellant rocket engine and a molar blast fragmentation warhead weight to 40.5 kilograms, the RIM-7 Sea Sparrow can propel with maximum speed of up to 4,256 kilometers per hour at an effective range of 19 kilometers. Moreover, as a short-range, semi-active homing missile, the RIM-7 Sea Sparrow uses radar uplinks or pulsed Doppler radar energy to make flight adjustments and is launched from the Mark 57 Sea Sparrow missile system, the Mark 29 guided missile launching system, as well as the Mk-48 guided missile vertical launching system. When the missile is fired, the launcher would automatically follow the illuminator's motions so that it could observe the signal being reflected off the target right away. These make RIM-7 missile enabled to provide reliable ship self-defense capability against a variety of air and surface threats, including anti-ship cruise missiles that travel at high speeds and at low altitudes. Therefore, the RIM-7 Sea Sparrow becomes effective as an anti-aircraft and anti-missile weapon system to defend against anti-ship missiles. Since its first deployment in 1976, the RIM-7 Sea Sparrow has been widely used by the U.S. Navy, NATO, and other NATO's international partners. By January 2019, A unit of RIM-7 Sea Sparrow costs $165,400. It is also important to note that this RIM-7 Sea Sparrow has a series as part of Raytheon's upgrade program. Some of them include RIM-7E, RIM-7F, and RIM-7M. The original RIM-7E version had a range of 15 to 22 kilometers and could fly at Mach 2+ between 30 and 15,000 meters, depending on the target height. Meanwhile, the RIM-7F improved the performance of the previous version, including the proximity fuse against low-flying targets by reducing the minimum altitude to 15 meters or less. On the other hand, the RIM-7M could hit targets from an altitude of 8 meters, giving some protection against sea-skimming missiles like the Exocet. Despite the upgrade program of the RIM-7 missile in particular, the Raytheon Missile Systems has also designed and manufactured the latest variant of the RIM-7 Sea Sparrow, namely Evolved Sea Sparrow Missile Block II. So, how does the Evolved Sea Sparrow missile differ from the initial RIM-7 Sea Sparrow? The Evolved Sea Sparrow missile, ESSM, is a medium-range, surface-to-air missile with Radar Intercept Missile 162, RIM-162. The missile is now in use by the U.S. Navy and several of the NATO Sea Sparrow nations. Naval combatants can rely on RIM-162 ESSM for its reliable self-defense and high firepower. This is mainly because the missile can defeat high-speed, highly maneuverable anti-ship cruise missiles, low-velocity air threats, high-diving threats, and surface-based targets. The ability which RIM-7 Sea Sparrow is not capable of. The RIM-162 ESSM also enables to engage attack planes, helicopters, and ships. Furthermore, the RIM-162 missile has been proven to successfully attack aerial threats during the Nimitz-class aircraft carrier USS Theodore Roosevelt's Combat Systems Ship Qualification Trial in May 2014, and the NATO Sea Sparrow Project Office also conducted a flight test of this new missile in 2020, intercepting a BQM-74E aerial target, which went successfully. That's all for today. If you find this video interesting, don't forget to like, comment, and subscribe. Thanks for watching, and see you next time.